This is your Learn Recording, Ions, Cations, and Anions, Part B. By watching this video, a student will be able to successfully meet the following learning objectives. I can determine the charge on an ion formed by elements in the main groups. I can determine the number of protons and electrons in ions. We will also add, I can name cations and anions because that's also on our lesson objective list. Number 5 says I can name anions and cations, so we will add that to our goals on slide 1. There are some good items to look at in our week 4 module to help us with this material. It is important to practice it before taking the quiz. There are some problem-like questions where you do have to calculate charge or determine the number of protons, electrons, and neutrons for a particular ion. You do have to know valence numbers and cation and anions for different types of elements and atoms. So you can look at the ion builder in week 4. There's also the game, the PhET Build an Atom. If you look to the far right when you open the program, at the game there are different levels, and there are levels that include ions. That's a good way to practice as well. There are some points that were in Part A recording that are essential for this recording and content covered. I'm not going to go over it in this recording just to help keep the length of the recording shorter, but just to remind you, the periodic table, we need to understand how group numbers are used to determine the valence electron number. We also need to know what valence electrons are and what the valence electron shell is. We need to know what the octet rule is and how we apply that to atoms and use it to decide whether they will gain or lose electrons. We looked at this in Part A video. Cations are specific types of ions. They are ions with a positive charge. So we also mentioned that there are certain types of elements that form cations. The types of elements that form cations are metal elements. So metals are going to form cations. So if you're trying to determine what types of elements form cations, well, we look for metals. We look for metal elements. And they do this by losing negatively charged electrons. There's the cation. She's wearing a gold necklace because she loves metal. Gold is a metal. Cations are ions with a positive charge. Electrons have a negative charge. If we want to become positive, we can do that by getting rid of negative stuff. So we will get rid of electrons in order to become positive. So they lose electrons to become positive. So something like calcium with a 2+ charge as a cation, it's counterintuitive because we see 2+ and it looks like it gained 2 things. But in order to become 2+, that means it lost 2 electrons. Because you have to lose negative things to become positive, and it lost 2 negatively charged electrons. Lost 2 electrons. So the charges and the process of losing or gaining electrons does need some time to work through and practice because it is a bit counterintuitive. It's not straight math. It does not work like straight math because we're talking about charges and not just the addition or subtraction of items. We can use this rule. Elements in the groups 1A or 1 through 3A or 13 are going to form cations. So that's going to be a good rule to really help us out a lot in terms of what will form a positive ion. There is a ion builder activity, a simulation in week 4 that will allow you to practice this idea and see what happens when you take away or add electrons. And it will help you convince yourself that when you lose electrons, you become positive. And when you gain electrons, you become negative. So there's a link here, and you can try this out. Build an atom with 12 protons and 10 electrons and see what you get. See if that gives you something positive, a positive cation. So that's a good program to try and work out the positive, negative charge of the ion with the loss and addition of electrons. Okay, then we have this excellent summation, a great reference for you. This gives you the visual for what elements are going to form cations, So this is showing you what ion and the charge the elements in this group form. What ion and the charge the elements in this group tend to form. The ion and the charge the elements in this group form. So that's really handy dandy and great to have, to take a snip of, to take a screenshot. That's going to come in. It's really going to help you out if you have that handy. Now, this is something we did not spend any time on in part A. How do we name a cation? How do we name a cation? We name a cation by using the name of the metal, just writing the name of the metal, and then adding the word ion. So, for example, the lithium ion or lithium cation is simply lithium, the name of the metal, and then you add the word ion after it. So for the cations, it's really straightforward. For the cations, it's straightforward. We use the name of the element and we add the word ion. So you can see all of these are positive, and they all have the name of the element, the name of the metal, followed by the word ion. So that's straightforward. Remember, anions are negatively charged ions, and nonmetals form anions. So the nonmetal elements, we need to know where those are and know that those are the ones that are going to form negatively charged ions. A negatively charged ion will have a charge and look like something with 2 minus, 3 minus. That's what the charge of an anion looks like, or just 1 minus. We have Annie the antion to help us remember. She eats electrons for lunch. That's why she has a negative sign in her abdomen, because she just ate another electron. Oops, I ate another electron. Nonmetal atoms become negative by gaining electrons. And a good thing to remember, something that's been worked out and will be handy for us. Elements in groups 5A or 15 through 7A or 17 are going to form anions. How do they become negative? Well, remember, electrons are negative. So in order to become negative, to become something like a 2- anion, well, you have to gain or add more electrons. So you have to gain electrons to become negative. So they're going to add electrons. That's how anions become negative. They gain electrons. All right. Again, this is handy dandy for us. This again helps us a lot because it gives us a trend in group 5A or 15. This shows you the ion, the anion, and charge that these elements form. In group 16 or 6A, this shows us the anion and the charge, the value of the charge that these elements form. And we also have this for 7A or 17. The noble gases are not going to form a charge, an ion, so that's why it says 0. How do we name an anion? How do we name an anion? Well, this is different. This is not as straightforward as naming the cation. So we do have to do some work on these. The name of the anion is the following. You take the name of the nonmetal, and you need to change the ending to IDE, and then follow this by the word ion. So for example, if we think of the word fluorine, that's the element name, how are we going to name the fluorine anion? Well, what do? We have to change the ending to IDE. So we're going to change the ending from INE to IDE. So now it's fluoride, and then we add the ending ION. Fluoride ion. And you may have heard of the fluoride ion because the fluoride ion is found in your toothpaste. The fluoride ion is key to cavity prevention, to healthy teeth. So for naming an anion, we do need to have a couple steps to get that final answer. Change the ending to IDE after you get the name of the nonmetal, and then add the ion to that word. Okay, then we're going to look at just a couple practice and call it a video. Remember, we need to keep track of our isotope ion notation. We've looked at ion notation, but now let's just make sure we can add an ion. The charge is always in the top right superscript position. So now you might have all three items listed. You might have the mass number, atomic number, and charge around the symbol. The charge is always going to be in the superscript position on the top right. So that's the key for isotope ion notation. Some things to keep in mind. The atomic number equals the number of protons. The mass number is equal to the number of protons plus the number of neutrons. And the charge, this is one way to calculate charge. If you're given certain information, or if you have two, you can solve for the third. Charge equals the number of protons minus, that must be minus, number of electrons, and it has to occur in that order. It cannot be the it cannot be the number of electrons minus the number of protons. It must be in that order. All right, let's look at a problem. Let's look at this problem. Let's say we have, whoops, somehow I made a mistake there. Let's try this one. Didn't match my name to my image. Sorry about that. Let's try this one. We'll have to just sort of change the name. I apologize. I wanted to do one with a calculation. There we go. Let's do this one. I apologize. All right, so we have this potassium ion, and we need to know how many protons, electrons, and neutrons are in it. So how do we solve this? Answer the question. Well, remember, the lower left, that's the atomic number. The atomic number is always equal to the number of protons. So we have 19 protons. We have 19 protons. Now, in order to determine the number of neutrons, we take mass number. Mass number equals the number of protons plus the number of neutrons. Okay, and our mass number is 41. That's in the top left. Okay, so 41 equals 19 plus the number of neutrons. So what are the number of neutrons? Well, 41 minus 19, what is that? That's going to be 22 neutrons. So both of these have 22 neutrons. So now we have to think about how many electrons. Well, we use this formula right there. Charge equals number of protons minus number of electrons. So the charge is positive 1 equals number of protons, 19, minus x. 19 minus what equals 1? 19 minus what equals plus 1? Well, 19 minus 18 equals 1, equals plus 1. So we have 18 electrons. So our answer is A. So that's how you can solve a question asking you about the protons, electrons, and neutrons. And then if we wanted to ask about what the name of the name of an ion was, what is the name of the sulfur ion? Well, remember, you have to know if it's negative or positive because the rules for naming are different for cation and anion. This is an anion because it's negative, and the rules for naming an anion are, remember, you need to take the name of the nonmetal, that's sulfur. You need to change the ending to IDE, so we have to drop the ending and make it IDE. And then we have to add ion. So our name is sulfide ion because this is an anion, and those are the rules for naming anions. All right, have a great day, everyone. Take a look at some of the other slides, open them up, and look at some of the practice questions. Bye, everyone.